Alright, good evening. We got a break yesterday from the videos, so we're back at it. Okay, so what we're doing here is we're doing what's called the difference of two squares. And I want to circle this word here, difference. You know when you see the word difference, that means subtraction. And we'll talk about what the two squares are, but it has to do with the square root. Okay, so let's look here. If we go back in time and we remember foiling, right? We have two binomials that we're multiplying together. We have x times x, and that gives us x squared. That's the first. Outer gives us negative 5x. Inner plus 5x. And then the leftovers gives us negative 25, right? So if we combine that, these cancel out to 0, negative 5x and positive 5x. So you're just end up with x squared minus 25, right? Okay, well x squared and 25 are what we call perfect squares. And the reason why we say that is because x squared is x times x, and 25 is 5 times 5. Okay? 5 times 5. Those are both perfect squares. So even though there's a minus here, a subtraction, this is still a perfect square because it could be negative 5 times a positive 5, right, to get a negative 25. So when we want to talk about factoring, which is what we've been doing here, we're going to factor x squared and a negative 25 into two parentheses. We're going to one term and two terms, right? The first term, or the first number, must multiply to be x squared. So what is multiplied to be x squared? X times x, right? That's what multiplies to be x squared. The second number must multiply to be 25, but they have to add to be 0. Because remember here when we were doing 5x minus negative 5x and a positive 5x, those equal 0. So they have to multiply to be 25, 5 and 5, but add to be 0. So really, how do you get something to add to be 0? Two numbers to add to be zeros? Well, one has to be a positive number and one has to be a negative number. So the positive and the negative number will always be 1 plus and 1 minus sign. So when I say 1 plus and 1 minus sign, I'm talking about in the original here. You have to have 1 plus sign and 1 minus sign in the original binomial you're multiplying. Because you're going from here to those binomials. That's what we do when we factor. We go backwards. It's backwards foiling, remember? So let's do some examples here. X squared minus 100. We're going to factor those into two binomials. You know it's going to be x and x because that equals x squared, right? And then you have 1 plus and 1 minus because that's what you have to have when there's a negative number. And take the square root of 100, and what is that? 10. So x plus 10 and x times x minus 10 is going to equal x squared minus 100. Because a positive 10 and the negative 10 is going to equal 0. Okay? So let's do this one here. We know we have x and x equal x squared. We have a plus and a minus, always, in the difference of squares. And then what is it that equals 4? What's the square root of 4? 2. Plus 2 minus 2. Super easy, right? X minus 9, right? So this one is x plus 9. And you know what? If we were to factor these, if we were to FOIL these, you would get this answer. Because you would have a negative 9x and a positive 9x that would cancel out, and you would just be left with x squared minus 81. Okay? So over here, we have 64. One's going to be plus, one's minus. Square root of 64 is 8. So difference of squares, okay, is pretty easy. Let's do one that's not x squared. Let's look down here at number 6. So remember, when you have to multiply something to get x squared, your first two terms have to multiply to be x to the 10th, not x squared, x to the 10th. So we have to make these terms have exponents that when multiplied together, when these two terms are multiplied together, they equal x to the 10th. Well, when you multiply exponents, what do you actually do? You add them. So if we had an x to the 5th and an x to the 5th, and multiplied those together, wouldn't that be x to the 10th? Because you would add 5 plus 5? Yes. So the other parts is the same. We have a plus and a minus. 49, so that is a 7. That's square root of 49 is 7. Okay, so let's look at number 9. Now number 9 introduces coefficient in front of the term, the x squared term. So let me zoom in here on this one. Okay, so we have 9x squared minus 100. So we've been factoring. What times what goes into 9? 3, right? It needs to be the same number. 3, 3, and then x squared is x and x. So now we can check it. Would 3x times 3x, would that be 9x squared? Yes. So that would be right. I mean, that's going to be our first step in foiling. So we have a plus and a minus because it's the difference of squares. You have to have one positive, one negative, and then 10. All right, 10 times 10 equals 100. So see if you can do number 10. What times what would equal 4x squared? 2x, 2x, plus, minus, 5, 5. And then let's skip 11. I want you to see if you could do that one on your own. Don't get confused with this 1, because what times what equals 1? 1. Okay, and then you can figure out the 100x squared part. Let's just end here with number 12. Do number 11 on your own, but let's end here with number 12. So I'm going to move my camera down. What times what equals 64a squared? 8a. Hopefully you said that. 8a times 8a is 64a squared because we add these a's together, and that's going to give us a squared. Plus, minus, ooh, looky here. We have another term with a letter. So, we know that the number here, what is the square root of 49? 7, right? But there's a b to the 6. So what times what equals b to the 6? It's b to the 3rd, right? b to the 3rd times b to the 3rd. We add those. I have to erase that. I'm sorry. It's b to the 3rd. Okay? So this is actually, I'm going to rewrite this. Minus 7b to the 3rd. There you go. Because 7b to the 3rd times negative 7b to the 3rd would equal negative 49b to the 6 because you add the exponents. That's it for tonight. I want you to do the ones that we didn't do here, these easy ones up here, and then number 11 as well. And I'll see you tomorrow. Good night.